Right? For those who remember, I would like you all to draw the two main types of graphs for me. Right? I want you to draw the two types of graphs and see if you remember anything. I was going for an napkin. Right? There are two main types of graphs. If you remember what they are and what are the important things about them. Right? And then you'll have no what are the Right, so what are the two main time graphs, Bradley? What are the two main time graphs that you have to learn in math? Distance time graph and velocity time graph. So before we do that, let's just run over some quick definitions, right? I'm not sure how much you all remember these things. I want to just go it over fast. Right? So the first thing we need to remember is D is distance. Right? Distance is the total length traveled and it's in meters. Okay? Then you have S, and S for displacement. Same SI unit. Right, but I wanted to remember what is displacement. Everybody watch here, please. Let's say Frankie start right here, right? Frankie start, then run a little race. So he ran a race like this. And finish here. Start here and finish here. What is the total distance traveled by Frankie? All this, right? That's total distance. But total displacement is what? Straight line distance from when Frankie start to when Frankie finish. So this here is Frankie's displacement. All right. Let's do my favor. Right, that's it, please. Right, displacement is your straight line distance from start to finish. Straight line distance from start to finish. Right, so here to here is the displacement, and this whole distance is your distance. Right? So we also need to know about speed. What is speed? Speed is your distance traveled all over time. That is the speed. So the speed is distance divided by time. Okay? And the SI unit for speed, I'll write it underneath here, meters per second. Then we have velocity. That's a little bit different. Velocity is your displacement divided by your time. Same SI unit, right? Same SI unit. Are you okay there? Online? You'll see that clearly there, right? Ravina, you'll see the whiteboard clearly, right? Lorraine? Yeah? Okay. Right, so we need to know what is displacement, distance, speed, velocity. So if I ask you to find velocity, you give me distance divided by displacement divided by time. And last thing they like to ask is what is acceleration? Right? And your acceleration is what? Ricardo? What's acceleration? Something over time, so you get that part right. What is something in? Something is change in velocity. Change in velocity. Okay? So those are the things that we need to know before we start time graph questions, right? All right, so we want to be able to explain these graphs now, right? We want to be able to explain those graphs. So this graph, both of them do the same thing. Both of them start at 0, they went up a little slope, they stayed horizontal, then the slope come back downwards, right? We're going to talk about what everything means. Here, same thing. Start at 0, they had a nice steep gradient, then stayed constant for some reason, and then they went back down, right? We're going to explain each phase, and you're going to find whatever you need, right? So before we do that, anybody remembers for a graph like this, right? What does the gradient give you? The gradient gives you whatever on the y divided by whatever on the x, right? So what is displacement divided by time? Velocity. So the gradient of a displacement time graph gives you velocity. Are you okay with this? Right? So the gradient of a graph like this gives you velocity. Displacement divided by time. All right? So, Yolanda, what is the gradient of of a graph like this give you? What is velocity divided by time? Which one? Acceleration. Velocity divided by time. Right? Velocity divided by time is acceleration. And then this one, not that one, the velocity time graph, gradient is acceleration, and you can find this area here. This area under the graph, this area here, area under the graph is equal to distance traveled. So people doing physics, that should be kind of easy, right? Actually, yes. We have a little problem with the crash course so much, right? Not much people have to take it to right? The game shifted when they called it as next time one time. What if they put up a new one? Oh, yeah, I'll send that. Since you already have the one, I'm very keen. It's possible to do. Right. Good. So we need to understand what the graph is saying. So let's start here. What is graph saying? This graph saying that at time 0, we want displacement 0. So it's at some starting point. And as the time increase, the displacement increase. So you move further away from a starting point. What is horizontal line saying? It's saying displacement staying constant over time. So what does that mean? If a displacement not changing but time changing, it means that what? It means that you are stationary. So you're not moving. Time going, but your distance not changing or your displacement not changing. And here, because the answer went back to 0, what you can say is that your displacement, right? Your object or wherever it was went back to the starting point. Okay? If your displacement is 0, it means that your distance between these 2 points is 0. So it means that you went back at the starting point. Okay? So that's what displacement, that's what here means. If your displacement is 0, it means if you start at A, you went back and you finish at A. All right? If your displacement is 0. So this object moves with a velocity here, remain stationary here, and then return to the starting in the opposite direction. That's okay? You'll recognize here is positive and here is negative, right? So it's showing here that you're changing direction. One direction like this and one the other way. Does this mean you're moving up a hill? No. It can just mean you start here, you went to some point, you take a rest, and then you come back here again. That's okay? That's what this graph here is saying. Okay with that? So during this point here, constant velocity. So you move with a nice constant velocity. Here where you stay, where I stayed stationary, and here's where I return. All right. So write the sum from 0 to T1, from 0 to T1. From 0 to T1, the object moved with constant velocity. From 0 to T1, the object moved with constant velocity. Right? From T1 to T2, the object was stationary. Right? Here is stationary. From T1 to T2, the object was stationary. and T2 to T3. What I will say again, Keelan? What I will say from T2 to T3. Went back to the original spot in, that's it. So you move with constant velocity in the opposite direction back to the starting point. Okay? So you move with constant velocity. Move with constant velocity back to the starting point. Back to the starting point. You okay with that? Right? So if you see a graph with displacement and time, all you can get is things that we talk about. All you can get is velocity. Or if it's not moving. Nothing to do with acceleration, right? This graph now is the one that will give you acceleration. All right? So what you would say happened from here to here. So the body accelerates until T1. What happened here? Constant velocity, no acceleration. But it's still moving, right? This line means moving in a velocity graph, right? This means that the velocity is staying the same, but the object's still moving. And this means what? It means that it decelerated. So it's slowing back down, right? It's slowing down until the velocity is 0. Okay? So here is constant acceleration. Here is constant velocity, no acceleration. Here is deceleration, back to rest. And underneath here is what? Right? Underneath here is what? Which gives you the what? Right? So underneath here gives you an idea of the distance traveled. Okay? Write up, please. Each one, right? All right, so now that we have an idea. Oh, by the way, why is my A ever shaped like this? Half the sum of the by the height. Or triangle, triangle, and rectangle. Okay? So you can use half the sum of the parallel sides by the height, or area of this, area of this, area of this. That's okay? So we can answer some questions on this numbers. Yeah? Height of the triangle.
Side of a rectangle.
Yeah.
Yeah.
So before you even start the question, right? Before you even start a question, the first thing you look for is what type of graph it is. All right. Let's take a look at these here. All right. So let's start with June 2017, right? I know it'll be a little bit hard, but I'm blowing up the graph there for you, and then we'll read everything off, right? You'll see the graph. Those who not seeing and want to send it back still, you can go to the handout, go to the topic by topic, and that's the first one we'll be doing on the velocity time graph. Right? In June 2017. Huh? You don't have to do it. You'll see the y and x values, right? Yeah? What type of graph is this? No, that's sticky versus time.
Yes.
Oh wait, but there's something to put into it. If you have a flyer cut off the wing, where you swallow it? Where you swallow it? I walk. All right. Good. So what's in there, right? What type of graph is that? A velocity time graph, right? So the slope part, 0 to 8. What happened in there? Find locus there, Shiva, you. We're going in from 4 to 8. Constant, all right, I'll take that. And A to B. Constant velocity. Oh, that was my joke. All right. All right, so find the gradient O to A and A to B. Yeah, go back up. Find the gradient, write it down. Find the gradient O to A to B. And I come back down. Find the gradient O to A and A to B. Do that fast. O to A to B. Alexa, you okay with that? Sure. Atilia, are you on your phone there? Find the gradient of O to A and A to B. Without working out A to B, the gradient is what? 0. Right? It's a horizontal line, right? Oh, you have to do O to A quick. Get the habit of writing what the units of degree, right? What's the unit of acceleration? Oh yeah, do that fast. Paper equals 15. Yeah? So the chart. What like this? Type it. Or is it? Right, so gradient here is 0, so we know that one. We could choose any point you want. You could choose 0, 0, and you could choose 25, 10. Please remember the x value goes first, then the y value, right? So the gradient will be 10 minus 0 over 25 minus 0, right? So I got 0 0.4, 0 0.4 meters per second squared. Right, remember the next method is rise divided by runner. So the rise is 10 and the run is 25, and you just divide them, right? 10 divided by 25. All right. To mark paper, write down the words. Write down the words there and then we'll go back and fill it out. Write down the words and then we'll fill out the blanks. Write down the paragraph there. And then we'll go back to the graph and all right, let's go through it, right? All right, so the cyclist from rest, where his velocity was what? What's his velocity at rest? 0, right? So the first part is 0. And steadily increased its velocity by how much? For the first 25 seconds. Right? So he steadily increased by how much? Take a look at it. Let's read it again. Now let's make sure. Steadily increases velocity by something each second during the first 25 seconds. Think about that. A tricky word there. What do you all think? Very good. The acceleration. Here's what the acceleration given you. The acceleration given you the change in velocity every second. Okay? Or, as some people recognize, divide 10 by 25. Okay? So that's what would have made it tricky, right? So this one is 0. Hold on.
Like this one.
Right? So the first one is 0, and then it increased its velocity by 0.4 ms minus 1 each second during the first 25 seconds. During the next 15 seconds, the velocity remains constant. That is, its acceleration is how much? What's the acceleration when the velocity is constant? Malini, what do you think? If the velocity is constant, the acceleration is what? Zero. Correct, 0. All right? So this was a tricky little piece here that you have to figure out, right? Right? And then the last part, find the average speed over the 40-second period. So I'm just going back to the diagram. How do we find average speed? I did not give it that formula. Write this down, please. Average speed is equal to total distance traveled divided by total time taken. Average speed, total distance traveled over total time taken. So, question to Atelier. Atelier, what's the total distance traveled from 0 to B? Huh? Pardon me? What's the total distance traveled? What type of graph is that again? A velocity time graph, right? How you get distance traveled on a velocity time graph? The area, right? So you have to find the total area underneath here, up till here, right? Look it out. What's the total time taken? What's the total time taken there, Josiah? 40 seconds. Oh yeah. Look on the area under the graph there. And divide it. Let's do it again. Shape and then So what's the area there? Right? So you have two options, right? Triangle and a rectangle or trapezium, right? So the trapezium looks like this. Right? The trapezium is half the sum of the parallel sides, 40 by what, 15? So right underneath, right on top here. Half the sum of the parallel sides, that's 40, plus 40 minus 25 is 15, by the height, which is 10. So that's 55 multiplied by 5. How much is that? 25. 275. Oh, yeah. 275. 25 is 4. So the answer is 275 divided by 40. 6.9 meters per second squared. Half the sum here. I'm going to show you again, right? To find the area of trapezium, follow the blue line. Follow the blue line, right? Half the sum of the parallel sides. Parallel side at 15, parallel side at 40, and the height is 10. So it's half of 40 plus 15 multiplied by 10. All right, nice. Let's go again. All right. This is June 2011, or if you have the handout, go to page 114. I give you some time to try this one. June 2011, number 9. You can go to the handout to take a picture of it and you cannot see it, right? Oh yeah, try that please. 114. Online, please message your answers as you get them, right? All right, this way coming up with. Right, so what we know about about acceleration earlier. Right? We know that acceleration is the gradient. And the question gave us the acceleration there, 0.6. All right, so here's what it said. The question said that the gradient here, or the acceleration here is 0.6 seconds. So we know that acceleration is 0.6 seconds. Right? But how do we find acceleration? Acceleration is equal to the gradient. Right, nice, Flores. So the acceleration is 0.6 and gradient is what? Y2 minus Y1 over X2 minus X1. And then cross multiply. X is 12 over 0.6, Ishana. So the answer is 20 seconds. X is 20. All right? So you have to use these things over there. You have to use this information given to solve it, right? What is the gradient of the graph during the second stage? I pick on Barrington. Second stage. What's the gradient? What's it easy? What's the gradient? The horizontal line for the gradient is? Any gradient? With horizontal? No gradient. Yeah? No, this would because the time was at 0, 0. Cross multiply. Right? So it would have been so the gradient is 0. So the gradient here, gradient is equal to 0. Explain in one sentence what the car is doing during this stage. Jacob, during this second stage, what you would say? The velocity time graph, right? Constant velocity, or so the object is moving with constant speed and no acceleration. Okay? So write that down, right? Sorry, don't say object. It's a car, right? Right? The car is moving with constant velocity. The car is moving with constant velocity or no acceleration. No acceleration. Both of them mean the same thing. And part 3. Part 3, they ask us to calculate the distance on the third stage. Are we doing that, Carisha? how we get in the distance traveled in the third stage. Right, so yes, so what Carisha said is to find the area here. Okay? Find the area in that stage. Right? Okay with that? Next one is yours. Find the area. Quick get some more here. So it's half of what? Base is 60 minus 25. And the height is 12. So the answer is how much? 2. 210 meters. See that? You get that? Yeah? Put together? Sure. Online? Any questions online? Let's go again, right? Samira, are you okay there? Harmony? Oh, anybody writing? Sorry. 210, right? All right, let's see if we can squeeze in one more now. All of them is the same shape, right? So I ignoring this one. And I'm finding the same shape just now. Aha. Right? June 2016. Somebody can just screenshot this and send it back in the group. So I'm gonna again. Hope you have the Wi-Fi password. Send on the group now. Let's take a look at June 2016. Oh, here, fine, all right. Did I add something already? And I physics? Oh yeah, check the group first. Those who not seeing, we share the group. Right, but this is a display, a distance time graph, right? So you're using these rules here. Not much rules. So you're focusing here now on the first graph that we did. Come on, everybody try this one. Let's see if we get it right before we go. Any rules there? Displacement time graph. Look at the graph. State the time of day at which the car arrived at C. What time they reach at C? Right, so they start 6 o'clock, 7 o'clock, 8 o'clock. Looking like in middle, right? Half 8? Half 8? By the way, every line is how much minutes? Every block? 15 minutes, right? It's important we know that, right? So the little block is 15 minutes. So they reach at C at 8:30. Calculate the total time in minutes for which the car stopped during the journey. Where is stopped here earlier? Okay then. Which part of the graph is stopped? Horizontal part. Do that maths in your head fast there. How many blocks is stopped for? 3 blocks, right? You're saying that? 3 blocks, so how much minutes is that? 45 minutes. 45 minutes, very good. You okay with that? Right, so 45 minutes, yours have rest for, right? Calculate the total, determine the constant speed during stage 2. How do we find speed on a distance time graph? How do we find speed? Use a relationship. How do we find speed here, Raj? But I want to use this relationship here. Gradient, right? So to find the gradient of stage 2, we'll give you the speed. Shiva? See that? You sure? Find the speed fast. Find the speed during stage 2. Find the speed, right? Gradient. Find the gradient there. Right? Don't let the horizontal part confuse. Actually, you know what? Here's a perfect example where rise over run is the best option to use, right? So the gradient is, this is your rise, and this is your run. Remember, gradient is rise over run. What is the rise? How high is that? Starts at 40 and finish at 100. 60 meters, right? Sorry, kilometers, right? You're okay with that? What is the run? How much minutes is that? 60 minutes. Oh, 1 hour. So it's 60 minutes. So therefore your answer will be 1 kilometer per minute. That make any sense? Now we never use kilometers per minute, but we use per hour. So instead of writing minutes here, we could write 1 hour. So the answer is 60 kilometers per hour. Right? They both mean the same thing. They both mean the same thing. Suppose I wanted meters per second. What to do? Well, convert the kilometers to meters and convert the hours to seconds. Right? That's an option if they wanted that. If they wanted meters per second, convert it to distance in meters and time to seconds. Right. The reason I show you this method here is that it might be tricky to read off the time, right? Because C will be 8:30 and here will be 7:30. Right? So you have to identify that 1 hour, not 100 or if you subtract 8.3 and 1.8, you might get 1, right? I still work with it, that might still work. All right, so the rise over run method is good there. Calculate the average speed of the car during the time it was moving. Calculate the average speed of the car during the time it was moving. How do we find average speed? Total distance over total time. So see if we can find the average speed of the car here. Total distance over total time. Oh yeah. Cool. While moving, take your time. So look at the graph and find the total distance and divide it by the total time. What's the total distance traveled in stage 1 phase? How much? Just read up the graph, right? 40. Nice. That's 40. How long it took? 1 hour. And you work in hours, right? 1. What about stage 2? How long? 60. Nice. How long it took? 1 hour. Nice. And stage 3. Stage 3 was how much meters? Or kilometers? Huh? 100 kilometers. And how long did it take? So that's looking like 1, 2, 3, 4, 5 blocks. How much is an hour? How much is 5 blocks? A 1, which is an hour and how much? A fraction. 1.25, right? As a quarter. Add up that. 200 over 3.25. So the answer is 61.5 kilometers per hour. Right? That is the total distance, average speed during which it was moving. Alright? So I want to learn these little things here, right? How to find gradients and what graph represents. Alright? Alright, online.